which says that when fx transforms to k times fx, and we are going to parallelly we are going to handle when fx transforms to fx upon k, okay, where k is greater than. Okay, so let us, so what we are going to see, we are going to observe a change in amplitude. So let us see with an example. Let us take cos x. Okay, so what is the graph of cos x? It's like this, where its range is from 1 to -1. Okay, so now what if we are told to make a graph of cos 3 cos x? Okay, so this is the graph of cos x. So let us make the graph of 3 cos x. So now if the range of cos x is from -1 to 1, then the range of 3 cos x is going to be from 3 to -3. So the graph will be like this. Its amplitude is increased. So this is 3 and this is -3. Okay, and cos x by 3. So this is going to become short 1 by 3, and this is going to be -1 by 3. There is no change along x-axis. The change will be along y-axis. Okay. So this was a transformation. Okay. So let us move to our next transformation. Where fx is transformed to f of kx, or fx is transformed to f of x upon k. Okay. So this transformation, if you see this transformation in any trigonometric quantity, majorly you will come across these kind of this transformation is going to help there majorly. So let us take example of sin x. Okay, so we'll better understand. So we are going to draw the graphs first of sin x. Now let us draw the graph of sin 2x. So here k is going to be 2. So very carefully we are going to draw. So let us project these points. Okay. So here we have somewhere pi by 2. So I'm going to draw the graph of this particular segment and then we can repeat it. Okay. And somewhere there will be pi by 4 also. Okay. So let us put x is equal to pi by 4 first. Okay. And here we'll have 3 pi by 4 also somewhere. Let me mark it here, 3 pi by 4. Okay. So 2 into pi by 4 will be pi by 2 and sin pi by 2 is 1. So, okay. Then pi by 2 into 2 is pi, and which is 0. Okay. And 3 pi by 2 is -1. And pi into 2 is 2 pi, which is 0. Okay. So what we can see is that the time period of the graph has changed. See, here only half oscillation was there within this interval. But we can see now there is one complete oscillation. And we already knew that when we'll have when the time period of fx is t and we multiply with some constant inside with x, then the time period becomes t upon k. And here in this case it will be t upon 1 upon k, which is going to be k. So now we know that when we take sin x by 2, then the time period is going to what? Of course increase. So this is your task to analyze. So you can pause the video and try on your own. Okay, I'm going to make the graph meanwhile. Okay, so where this graph was making one oscillation in 2 pi time period, since its time period has increased, so it has become slow, so it is only going to make half oscillation. I hope you all have understood this transformation is quite important. Okay, let's move on to next transformation. Transformation number 9. It says when fx is transformed to modulus of fx. Okay, so it says that take mirror image of negative y part in x-axis and then remove negative y part. So let us understand this with an example. Let us again take sin x. So we need to make the graph of fx is equal to mod of sin x. Okay. So as we know the graph of sin x, we'll do quickly. So this is going to be the graph. Let me extend it further. Okay, so we can see the negative y part is here. This. So what it says that definition says that we have to take its mirror image in x-axis, which is like this. So the graph of mod sin x, which we are going to obtain, is going to look like this. Okay, 0, pi to pi, minus pi, minus 2 pi, and so on. So this is the transformation. Very simple, I guess. Okay, let's move on to next transformation. So 10th transformation, where fx transforms to f of modulus of x. So here we are putting x as mod x. Okay, this is the transformation. So let us write the definition. So remove negative x part first, then take mirror image of positive x part in y-axis. Okay, so let us take an example where we need to draw the graph of fx is equal to e to the power mod x. Okay, so what transformation did we apply? We are going to first write our original function, which is this. So it's very easy. You all must know that. This is the graph of e to the power x. So what it says that so what is the negative part? This is the negative part. So we need to remove the negative part. That means we need to consider only this part. And then we need to take its mirror image about y-axis. So let me change the pen color. Okay, so let us take its mirror image, just like this. So our final graph is going to look like this. Sorry, not this. like this. I think we are done with all the transformations. Thank you.